Okay, so number 15 on page 297 says use the related graph of each equation to determine its solutions. Looking at this graph of the equation x squared minus 6x plus 9 equals 0, you can see that the graph only touches the x-axis one time. And that point is located at 1, 2, 3 over 0 up. So that's 3, 0. So that's number 15. So we have a point located at 3, 0. So that is our root. The 3 is our root. 3 is the root. So that's the answer. Because that's where it crosses the x-axis. Just that one time. So we only have one answer for this problem. Number 17. So number 17, if you look at your graph, so we have negative 0.5 x squared equals 0. Looking at this graph, 0, 0 is the only place it touches the x-axis. So that means our answer, or our root, is 0. So 0 is the root. Okay, oops, hold on just a sec. Okay, and then number 19, there are no real solutions because this graph is located below the x-axis. So number 19 has a no solution. All right. And now let's continue on and look at number 21 says that we have negative x squared plus 4x equals 0. So we need to solve this by graphing it. So the first thing we need to do is find what? Yeah, the axis of symmetry, right? Which is finding that x. Okay, which is x equals negative b over 2a. And so in this instance, we have negative 4 over 2 times negative 1. 2. So x equals 2. So then we need to make a table. Okay. Okay, so our x and our y. So we have our x values and our y values. So we know that we want our middle point to be 2, so we do 2 above and 2 below. Meaning, let's start with the lowest one. So we go 0 and 1, and then our 2 for x, and then we have 3 and 4. So we have 5 points, which will give us a nice graph. So then we take these numbers and we plug them into our original equation, negative x squared plus 4x equals 0. So we have 0 squared is 0 times that negative is 0 plus 4 times 0 is 0. So we have 0. Now we put in a 1. So we have 1 squared is 1 times a negative. So we have negative 1 minus 4 equals 0. Negative 1 minus 4 is negative 5. Okay, so now what happens if we put in a 2? What do you guys think? What do we get if we put in a 2? So then we get what? Negative times 2 squared plus 4 times 2 is 8. So we have negative 4 plus 8. 4. So now let's put in a 3. So we have 3 squared times that negative sign, so 9, so we have negative 9 plus 12. It's 3. Okay, and so now let's put in our 4. What happens when we put in a 4? We have 4 squared is 16 times that negative. So we have negative 16 plus 16 equals 0. Negative 16 plus 16 is 0. Okay, so now we need to graph these points. So the first thing you need to do is graph your 0, 0. So that should be plotted on your graph, 0 or 0. Then you go 1 to the right, down 5. Oops, sorry, that's not negative 5. That's why it's not working. Okay, let's redo that 1. So if you have negative 1 plus 4, that's 3. I put in too many. So we have 1, 3. But that doesn't work. So we put in 0, 0. Then we put in 1, 3. And then we plot 2, 4. Plot 3, 3. And then plot 4, 0. Okay, so Nina, we're going over number 21 right now. So we just made a table. We have our 5 points. And so Nathan, this is where we'll explain what the roots are. So if you look at this table you have. 0, 0, 1, 3, 2, 4. Okay, we're going over number 21. So we have a table, we have 0, 0, 1, 3, 2, 4, 3, 3, and 4, 0. So when we're finding our roots, we need to look for the y values that are 0. Because what that tells us, with the y value of 0, your x coordinate is your point is going to be laying on the x-axis. It's going to be on, and those are our answers. Our answers for a quadratic equation are the points that are on the x-axis. Those are our roots. So if we have 2 points that are on the x-axis, so we have 0, 0 and 4, 0, our answers are the x-coordinate of those points. So the answer for this problem is 0 and 4. Does that make sense, Nathan?
Okay, then what was the thing when you said the answer is between this and this?
Okay, so let's go over one of those now.
Right.
Okay. Well, let's see here. Yeah, so we did, so that's number 23. Okay, so 23 says x squared minus 2x minus 1 equals 0. Okay, so what is our axis of symmetry to start off with?
2.
Our axis of symmetry is 2. Because we have x equals 2 negative b, which is 2 over 2 times a, 2 times 1. So it's actually 1. Our axis of symmetry is 1. So x equals 1. Okay, so then when we make our table, we need to go 2 before and 2 after. So if x is 1, if x and f of x or y, so we have negative 1, 0, 1, 2, and 3. So that'll be 2 points before and 2 points after. And then let's plug those numbers into our quadratic equation. So we have x squared. So we have negative 1 squared minus 2 times negative 1. And that gives us 2, right? So it's negative, sorry. I keep doing this. So we have negative 1 squared is 2. We have 2 plus 2, because negative 2 times negative 1. So negative 1 is located at 4. Hold on. Let's start over again. Let's put in negative 1. Negative 1, you get negative 1 squared, which is 1, minus 2 times negative 1 minus 1. So that gives us 1 plus 2, which is 3, minus 1, which is 2. So what happens when you put in a 0? Okay, I want you guys to help out with this. I'm not going to do it all. I want to hear you guys working at this. Anastasia, you too. Okay, so let's put this in. So we're putting in a 0. So we have 0 squared we're putting in 0 for our equation of x squared minus 2x minus 1. 0, but you have that minus 1 at the end because it's x squared minus 2x minus 1. X squared minus 2x minus 1. Your C term is negative 1.
I think the Braille's wrong.
Isn't it 0, negative 1?
It's 0, negative 1, yes.
My Braille says it was a 0, not a 1.
It should be equals 0, but before the equal sign you should have a negative 1.
Oh, I missed that one.
Okay, so then let's put a 1 in. So you get 1 squared minus 2 times 1 minus 1.
Minus 2.
So you have 1 minus 2 minus 1. So you get minus 2. Very good. So now let's put in a 2.
I'll just subtract 1 from all my answers then.
There you go. Perfect. So then you get 2 squared. So you get 4 minus 2 times 2 minus 1. So 4 minus 4 minus 1. Minus 1. Now what happens when you put in a 3? 3 squared. 9 minus 2 times 3 minus 1. So 9 minus 6 minus 1. 2. Okay. So now, if you look at our answers, we don't have any zeros for our y values, do we? We have 2, negative 1, negative 2, negative 1, and 2. We know our vertex is at 1, negative 2. So just looking at our y value, what we're looking for is to see where it goes, it crosses that x-axis. Where it crosses the x-axis. So what we're looking for is when it goes from a positive number to a negative number, or a negative number to a positive number. So looking at our first two coordinates, we have negative 1 and 2 is our first point. And then our second point is 0, negative 1. So our y value jumps from positive 2 down to negative 1, which means it has to cross the x-axis, right?
Yeah.
So this is our first answer. Our first answer is somewhere between, so we write between negative 1 and 0. That's where our answer falls, somewhere between negative 1 and 0 on the x-axis.
That kind of flew over my head. Yeah.
Okay, so why don't we try this? Okay, so let's graph these. So I want everybody to plot the point negative 1, 2 on your graph paper. So do you have the pins and everything, Anastasia, to be able to plot this?
Oh,
Thank you. Okay, so Nathan, I want you to do that too.
Put a point at 0, 0.
No, at negative 1, 2. You want to point there. Okay, I'm going to pause this for a moment. So once you've plotted those 2 points, put your wiki stick next to it. And what you will see happen is see how your line goes from in like quadrant. It'll go from quadrant 4 to quadrant, which is that?
2 and 3.
Well, it goes through 0, negative 1. So it kind of goes through, yeah, it passes into the other quadrants, right? So do you see how it passes over the x-axis? It changes quadrants vertically. So that's another way to say it. It's like when your graph changes quadrants from either 2 to 3, or it changes from 4 to 1, or it changes from 3 to 1, it's going above the x-axis. So that's really what you're looking for, seeing how your line goes across that. So that's why it's saying it's between this and this, because your point is not exactly a whole number. It could be a half, it could be a negative half, it could be negative 2/3, or 0.666587, whatever. So that's why you say it's between, because you can't get an exact number when you're just graphing it. So let's look at the other one. So our y values, we went from 2 to negative 1, so we said yes, it crosses the x-axis. Then the next one is negative 2, so we're still down in the lower quadrants. And then negative 1 is the next one. But then between negative 1, it pops back up to a positive 2. So we know that's our other root because, again, it crosses back over up into the positive y values. And that's somewhere between 2 and 3 for x coordinates. So now plot the points 2, negative 1 and plot 3, 2 on your graph. So the first one was 2, negative 1. The second one was 3, 2. So the second answer would be between 3, it's between 2 and 3. Okay. All right. So Nathan, does that make a bit more sense?
Kind of.
Okay. So where it's just falling somewhere in between 2 and 3. We don't know where exactly. We don't have enough information to tell us exactly. So then number 25, that one actually we get whole answers for. And those answers are 3 and 6. And then 27, we only have one root, and that's at 6. And then 29, we have an answer at negative 1/2 and an answer at 2 and 1/2. And then we did number 37. So 37, there are no real solutions. And I wanted you to graph this one because I wanted you to see where it kind of landed. And this one does not cross the x-axis. It's a downward opening graph that does not cross the x-axis. Okay, so that is the homework. Talk about solving quadratic equations by factoring. And we all know what factoring is. Okay. So we know that in when we're doing our graphing that at least one of our factors was 0. So let's first look at how we do this. So we have an example. This is example 1. This is for 2 roots. This is for 2 roots. We have an equation that says x, oops, my pen turned back to yellow. Okay, we have x squared equals 6x. What's the first thing we need to do when we see something like this? That quadratic equation. How do we put this into quadratic equation?
Move the 6x over and look to the left side.
Right, exactly. So we have x squared minus 6x equals 0. We're on page 301. So now we need to factor this. We need to pull this apart. We don't want any squares. We want them to be just single x's. So how do we factor out x squared minus 6x? What can we pull out of each of those terms to simplify it? An x, right, we have an x in each term, so we can pull that out. So Anastasia, what will it look like when I pull out an x? We have x squared minus 6x. We can't just get rid of them, we just need to pull them out. Because right now the x is x times x minus 6 times x. Think about when you're factoring this out, when you are, it's basically the reverse of distribution. So that x that you want to pull out is distributed to each one. So what would it look like? Anybody want to help Anastasia with this? How do we factor x squared minus 6x?
Do you need to have a 0 in there to be a c?
Not right now. No, we don't. Because it's implied. So how about Nina? How does this look when you factor it?
So it'd be x left paren, x minus 6 right paren?
Exactly. We pulled an x out of each one. And so if we were to multiply that x back, we get x squared minus 6x again. So now, Nathan, now we have x open x minus 6 equals 0. So we still have to have it set equal to 0. So we can pull these apart, and it's called the zero product property. So we can say we set each of these terms equal to 0. X equals 0 and x minus 6 equals 0. Okay? So when you factor things out, you know when we were factoring and we ended up with two binomials to make a trinomial, because the quadratic equation is a trinomial. You set each of those terms equal to 0. So we have x equals 0 and x minus 6 equals 0. This will give us our answer for our two roots. So we want everything to be just a x equals. Get the x by itself. Our first one is there. So we have an answer set of 0. And now with x minus 6, what would it be? When we want it to be x equals whatever.
X equals 6?
Exactly, x equals 6. So we'd write this as open brace, 0, comma, 6, close brace. And we use brace and not parentheses because we don't want it to look like an ordered pair, we want it to look like a set, a solution set. So the two roots are 0 and 6. So this is how you can do it without finding your axis of symmetry and without graphing it. But these 2 points, 0 and 6, in this equation is where it crosses the x-axis. Okay, so now here's another one. Let's go through this one. This one says 2x squared plus 7x equals 15. First things first, we need to put it into quadratic equation formula. So what would that be?
2x squared plus 7x minus 15 equals 0?
Yes. Minus 15 equals 0. Okay, and this is factorable. So we want to factor it into two binomials. Okay. And how do we do that? Remember, this is the reverse of basically FOIL. We have our first terms, we have our last terms, and then we have a sign in between. So we have a 2x squared. How do we break that one apart? So you should set it up. You have open parentheses, a bunch of space, close, open, space, close. So we're just going to factor this guy out. So 2x squared, we're going to pull that apart. So right after the first open paren, we have 2x. And then, yeah, we're factoring it. But then the other x needs to be the first term of our second binomial. So an x goes there. So now I have open 2x, some blank space, close, open, x, then a bunch of blank space that we're going to have to fill in. So we just factored out our first term. And now we need to ask ourselves, what are the factors of 15, of negative 15, that we can use so we end up with a middle term of 7x when we FOIL it back out? So what are the factors of negative 15?
3 times, well, no, that doesn't work.
Yeah, 3 times 5, right?
Yeah.
Or one of them has to have a negative,
Yeah.
and then 1 times 15. Those are the factors. Okay, so how can we strategically place our 3 and a 5? We know 1 and 15 are not going to work. So let's look at the 3 and the 5. How can we strategically place these that when we use the FOIL method, we end up with a 7x in the middle? So let's just try and throw that 5 at the end. The 5 as the second term in the second binomial, and let's throw a 3 in the first one and see if that works.
Minus 5 in the second?
What do you want to try? Do we want minus or we want plus? We want it to end up as a 7x.
Or should we put the minus 5 in the second set?
You wanted a minus or do you want it a positive?
I don't know.
Let's kind of look at it. We want it to be 7x. And we want it to be a positive 7x. So the first thing, we need to look at multiplying our outer terms and our inner terms. So right now, if we have open 2x, positive or negative, we have decided, and then a 3, and then our second one is x plus or minus 5. Where do you want to try the negative sign first? Anastasia, where do you want to put it? The first one or the second one for the negative? You want to put the second one. Okay, so then we know it has to be a positive and a negative because our last term is a negative number. So we have 2x plus 3 times x minus 5. Let's multiply that out and see if it works. So do FOIL. Front terms, 2x times x squared times x gives us 2x squared. So far so good. Outer terms is 2x times negative 5 gives us minus 10x. The inner term is plus 3 times x, which is plus 3x. Last term is 3 times negative 5, which is negative 15. So now the thing we need to look at is, look at this middle term. We have negative 10x plus 3x. What does that give us?
7x.
What kind of 7x though? And do we want a positive or a negative?
Positive.
Right, and we ended up with a negative. So what does that mean we need to do? Yeah, let's switch the negative to the first one. So let's try that and see what happens. Okay. So let's try that. We'll put the negative on the 3, and we'll put the positive on the 5 and see what happens. Okay, Nathan, walk through this with me foiling it. We have 2x minus 3 times x plus 5.
Hold on.
Sure.
So you get 2x minus 3. And then x plus 5.
Yeah, 2x minus 3 times x plus 5.
And the first would be 2x squared.
Yep.
Outer is 2x times 5 is 10x.
Right, test plus 10x
Minus 3x.
minus 3x.
And then the last one would be minus 3 times 5, which equals negative 15.
Right, okay, so now just combine your middle terms. So you have 2x squared.
Plus 7x.
Yep.
Oh, yes.
Minus 15.
Right, and so it brought us back to where we want to be. So we know the right way to do this is 2x minus 3 times x plus 5. So now we set each of those terms equal to 0. So what that looks like is 2x minus 3 equals 0, and x plus 5 equals 0. And now solve for your x and see what you get. What do you get when you have 2x minus 3 equals 0? What will your answer be?
X equals 2/3.
X equals 3 halves.
Oh, 3 halves, sorry.
That's all right. And then we have x plus 5 equals 0. So it's our second x.
X equals negative 5.
X equals negative 5. Right. So those x equals are our answer. So you have open brace, 3 halves, comma, negative 5, close brace. And that's your answer. Those are your two roots. Those are the two locations that your line passes the x-axis.
Oh.
All right. So now there's times when you get a double root, which a double root is, the name is a little bit deceptive. A double root means that you actually only have one answer. So double root means it lands on the same spot. Like in the case of x squared minus 16x plus 64 equals 0.
Can you read that again?
Absolutely. X squared minus 16x plus 64 equals 0. So now, since we only have just a plain old x squared, we don't have a number in front of it, what do we know about a problem like this? We have a minus 16x and a plus 64. What do these guys have in common?
For both factors of 8.
Yes, they both have 8 or both factors. Nice job.
Both factors of 16 too.
Well, yes, exactly. But think about this. What factors of 64 add up to negative 16? Is there a factor of 64 that you can then add and then get negative 16?
Negative 8 and negative 8.
Negative 8 and negative 8. So, what do our two binomials look like? Because we know,
Something minus 8 and something minus 8.
right, exactly. And if you look at your first term, that'll tell you what that something is. And our first term is x squared.
X minus 8.
Yep, x minus 8 and x minus 8. So then you set them equal to 0. X minus 8 equals 0 and x minus 8 equals 0.
X equals 8, x equals 8.
Right, so our solution set is just 8. So that's why they call it a double root, because it's the same thing. It's the same spot. But you only have one answer. All right. And I don't want to go any further today since it's the weekend. Okay, I'm going to record that last piece. So we're going to be doing 4, 6, and 8 on page 303 for in-class practice. Number 8, we have 4x squared minus 13x equals 12. We move that over, we get 4x squared minus 13x minus 12, yeah, equals 0.
Yeah.
Okay, now let's look. So, what are all the factor pairs of negative 12?
There's 1, 3, 4, 6, and 12.
And 2. 3 times 4, 6 times 2, or 1 times 12. Okay, so what we need to do is we have to set up our two little sets of parentheses.
And the 1 times 12 would work, I guess, because that's 13.
But we have this 4 in front of our first term, which is going to mess that up.
Yeah.
So we need to think about, okay, do we split that first one up into 2x times 2x, or do we have 4x times x? What would work?
Do the 4x times x.
So 4x times x, let's try that and see what happens.
So you do 4x open x.
So open, no, get the two sets of, the two sets of parentheses. So you have, if you want to do 4x and times x, so that 4x goes in the first spot of your first set of parentheses.
Yeah, right.
Okay, and your x goes in the first spot of the second. Okay. So now looking at this, looking at the factors of 12, is there something you can do that where you can break this up so you get a middle term of negative 13? So first let's look at 3 and 4. What if we were to put 3 and 4 in there? So let's say you put the 3 for your first term in the first binomial and your 4 in your second.
We get 4x plus or minus 3, and then x plus or minus 4.
Right. And then you say, ask yourself, does that work?
I don't think so.
So let's go through it. So let's do our first term. We know our first term is going to work. That's a 4x squared. Now our outer term is a 16, right? Because it's 4x times 4. Then you get a 16x. And then you have another one. You get your middle term. Your inner term is a 3x because it's 3 times x. And your last term is a 3 times a 4, which is 12.
Okay.
Okay. So now I wrote these down, but I didn't put any signs in between them. So I didn't put any, real quick. Can you, in looking at those middle terms, you have a 16x and a 3x. Can you somehow make those into a negative 13x?
Yeah, I can do like negative 16 plus 3.
Right. Okay. Right. And then we have a minus 12 to get our minus 12 at the end. So now we have 4x squared minus 16x plus 3x minus 12. So we ask ourselves, we want a negative 16, so which term does that negative go on? The first one or the second one if we want a negative 16?
The first one.
Because that first one will give us a middle term of a negative. If we put it on the second one, then that negative 4 for our outer term will make that 16 negative. So it's the first term of minus 16x, but you want to put it in the second term of our binomials. Because then that'll turn the 16 into negative, because then you get 4x times a negative 4. So you end up with open 4x plus 3 close, open x minus 4 close. So that's how that works. And then you just set those equal to 0. Yeah, 4x plus 3 equals 0. And then you get x minus 4 equals 0, and you get your two answers.